Welcome to CW 2.5. Today we're going to quickly review what you know about a function. So I put the formal definition from the book right here. The main thing to know is this, that each element in the domain corresponds to exactly one element in the range. So put simply, think of it as every x goes to one y. And one y is important. So if we're going to do these first couple, it says figure out which relation is a function. So a relation is simply like pretty much any set of numbers or any equation really. You can think of it as a relation between numbers. We're going to do like a basic technique you probably remember from your Algebra 1 days. Domain and range like that. Plug in your domain, plug in your range, and map it. So 1 goes to 6, 2 goes to 6, 3 goes to 8, 4 goes to 9. The question is, does this follow this rule? Does every x go to 1y? And the answer is yes. Every x is going to 1y. It doesn't matter that these two go to the same y. As long as each x goes to one of them, you're okay. So this is a function. We'll put a happy face right there. Let's try the next one. 6, 8, 9. 1, 2, 3, 4. 6 goes to 1 and 2. 8 goes to 3. 9 goes to 4. This is not a function, as you were probably thinking, because of right here. This 1x is going to two different y's, and that's what breaks the rule right here. So this would be not a function. Now, if we're going to figure out how to do it for an equation, let's look at these. X squared plus y equals 4. All you have to do, solve for y. So let's grab this one. Y equals 4 minus x squared. This means it's a function, because look at the value, or look at what we've done. Any x value plug in here is going to generate one value of y, no matter what you do. So if you're able to solve for y cleanly, essentially that means it will be a function. Now that might seem awkward because you're thinking like, well, I can always solve for y. What could possibly make it not a function? I'm going to show you B. For this one, when we solve, let's see what happens. Notice how when we square root this, something weird's going to happen. Recall from your algebra class that the root of y squared is not y. This is going to be the absolute value of y, and that's 4 minus x squared. And that's important because the absolute value creates a plus or minus situation where you get 4 minus x squared. So right here, this plus or minus means if you plug in some value for x, it's going to generate two y values. So that is going to make it not a function. And again, if you're wondering this part, definitely ask in class, but this is something you should have went over in your algebra class last year at some point. This is an important fact you want to write down. So definitely let me know if you're not sure what this means. Okay, two more. Evaluate. So for these, all we're going to do is plug it in. So we're going to plug in 2 for x. So that's going to be 2 squared plus 3 times 2 plus 5. 4 plus 6 plus 5. That's 15. Part A is done. For part B, we're going to plug in x plus 3. So let's plug that in. This is x squared plus 6x plus 9 plus 3x plus 9 plus 5, x squared plus 9x plus 23. Circle that. And the last one, plug in negative x. That's kind of cool. Let's plug it in. Make sure you put your parentheses here. That's important. So our answer is going to be positive x squared minus 3x plus 5. Now we're almost there. A couple more examples. Vertical line test to determine if these graphs are a function. So all you do, you draw a vertical line somewhere and think about, well, is that a function? This is not a function because you can see it fails the test. It hits 2 points. To pass the test, it has to hit 1 point. This is the graphical way to understand this, that every x goes to 1y. So for b, anywhere you put a vertical line, you can see it will only hit 1 point. So this is a function. Let's go to c. Yep, no matter where you put this line, that is a function. But look at d right there. Hits 2 points. That would mean that one x value is hitting 2 y values. That is not a function. Here's our last example. Find the domain range, x int and y int. Domain range. So remember, domain is possible x value. So look left to right. I can see my furthest x value is -6, but I can't include it because it's an open circle. The furthest x value is 0, and it is included, so I'll put a bracket. For range, we look up and down. So look, the y value down here is -3, inclusive, and it goes to 4, and we don't include 4. The x-intercept is -4, the y-intercept is -3. Our last example, same thing. Let's see, x-intercept, we don't have any, there's none. Y-intercept is 1. The domain, be careful here, this is 0 to infinity. Notice how we're starting at 0, this is our x value, we go forever to the right. And the range, the lowest y value is 1, so we're going to put bracket 1 to infinity. And that's it.